Hey guys, so we're gonna go over structural steel work. Now the thing is, I am not that good with structural steel work. Like I know 50% of the stuff, so I know a decent amount, but I'm not like as good as I'm in concrete, reinforced concrete. You know, my knowledge isn't broad in structural steel work, but I know a lot, and I'm still figuring it out. The reason why is because I did my in-service in reinforced concrete design, or like I was mostly involved in reinforced concrete drawings and so on, and I found concrete more, I found it more interesting than steel, structural steel work, but it was actually a good thing because now, I can actually, evolve myself better in another field, in civil. So like as long as you know the basics of how to how to extract information and gather resources, all of that, then you'll be fine. So I guess I'll figure it out on my own. By now I'm used to figuring things out on my own. So let's start. So basically, this is just introduction telling you what we're gonna do. So what I'll do is I'll read over this, and then I'll give you a brief point out of different points, in a structure, in a basic structure. Okay, so let's start. After starting this model, you should be able to use the different steel tables and codes to produce accurate, neat, and correctly dimensioned drawings of typical base to column connections, showing holding down bolts, typical welding and bolted column to beam connections, typical welded and bolted beam to beam, bolted beam to beam connections, and different types of welded and bolted roof trusses, lattice girders, and portal frames. Okay, so number one is your floor beams, and they usually your beams, your floor, first floor, second floor beams, they must be somewhere here. Let me just see. Okay, so there we go. That's a beam, so it's running straight through. That's a floor beam. Or it's not actually running straight through, it's running and then it's stopping at that column, then it's on the other side going to that column, stopping there, going through, stopping at that column. But it's basically connecting your main beam to your columns, because you can get secondary beams as well. You can see that's a number one as well, so that's also beam running there. That's basically a secondary beam running into your primary beam or your main beam. So let me just zoom in on that. It's that one there, and then that one there running there. And then you have your column holding down bolts. So basically it's like a U bolt or a J bolt, but I'm assuming it's supposed to be somewhere at your columns. The lower points of your, okay, there, number two. So it's like that one is like a L. It's bent into a L shape, but usually they use U bolts, because then you have a resultant force, and usually your resultant force is your biggest resistant force. That's one of the advantages of using U bolts instead of J bolts or L bolts, whatever you want to call them, looking like L shapes. And then you also have your base plate. Your base plates of steel columns. Your base plates are usually the ones keeping your plinths, or your plinths on top of your footings. Like in this case, there you have your base plate. It's on top of your column. So your base plate is what's connected to your U-bolts or your J-bolts. Like, let's just quickly zoom in there. So there we can see number 3. So what you also have is your beams, purl lines, and your girts. And usually, like, I won't say beams, because your beams can also refer to a floor beam, you know. So in this case, we also don't say purl lines, because your purl line, is basically, I'm going to give you an example of a purl line. But in this case, they talk about girts. Yes, your purl lines is basically this here. So that's your purl line. It's running, you know, on top of a what do you call it, a truss. So your purl line, there you have a purl line. That's a purl line. A purl line is usually on a horizontal plane. And girts, it's almost like it's running on a vertical plane. So your girts, when you refer to girts, you refer to these ones running on your vertical plane. And if you refer to purl lines, you refer to those ones running on your horizontal plane. But it's the ones just before you have your zinc, your zinc plate. So you have your plates or your zinc sheets, and then beneath them you have your purl lines, and that's how they are structured. So you have your zinc plates, which is your roof, number 16. Let's just see, number 16, light gauge cold form steel used to support floor and roofs. So it's basically a light gauge cold form steel. So just beneath that you have your purl lines. You have number 4, which is your purl lines. And then these ones is the same. You have your girts, and then your girts, you have your sheets, your zinc sheets or your roof sheets running on top of your, so it's gonna sit like that, and then you have your sheets on top of your girts. So your girts, they basically hold the sheets in place. It's almost like when you build a factory, like the sheets that's being held in place, they usually hold in place by your purl lines or by your girts. And then you have your bearing plates for steel beams. Now your bearing plates, they usually hold, or they usually bolt, you know, beam to beam. So it's like the connection. They just call it bearing plates, but it's the connection. Bearing plates for steel beams, or they connect beams with beams. And then you have your bracing for steel members or frames. So bracing is basically your cross braces. Like, it's just to prevent lateral movement, which is horizontal movements. So it's these ones here. There you can see number 6. That's your cross braces. So it's just to enhance your stability or your stableness in your structure. so that you don't have a lot of buckling. Like you will find cross braces or bracing everywhere in all structures, even in cars also, or in any type of, if people want to stiffen a steel structure, you know, like they do it in cars, like when you have a chassis, to stiffen the chassis they put in cross braces or braces, you know. So bracing, you find it everywhere. That's just to help you stabilize your structure. Number 7 is basically brackets attached to steel frame. So the brackets, it can be like, for example, there you have a bracket. It can be like a L shape, or it's just something that's holding, you know, for example, like it's supporting, you know, like maybe you have something running on top of it, so you put in a bracket, and then maybe like a shelf or something like that. Then you have brackets that you maybe weld on that side, and then you put on like a shelf, or like some type of for example, your girts. You can maybe attach your girts to brackets as well. But brackets, they usually support like another piece of structure or something. But it's important. It comes in a L shape, or like it's basically welding a piece of a L beam, or basically welding a piece of a L beam and then just inverting it. And then you have your columns, which is basically these ones running here. Number 8, there's a column. Let's see, maybe, okay, no. Number 8, there's a column. So these ones, they're all columns running in your vertical plane. There's a column and there's a column marked as columns. And then your conveyor framework, it's usually something that's carrying something from one point to another point. Let's just see conveyor framework. Like it's almost like when you have conveyor belts, you put it on top of that thing and it's conveying something to something. Just see. Oh yeah, conveyor. Oh, okay, so it's like a type of ladder structure. So maybe you have something sitting on the ground floor and you want it to go to the first floor. So then you have your conveyor belts running on top of it, maybe. So it's conveying, you know, maybe rocks or some type of material, cement bags or something. It's conveying it from your ground floor to your first floor. That's why they call it conveyor framework. So it's basically just a framework keeping conveyor belts maybe in position. So then you have your crane rail beams and slopes. So what I'm seeing here is number 10, and this is a crane rail beam, and that's also crane rail beam, but it's basically, I think it's placed in a form of a slope. But the function for a crane rail beam is, say you have you have your crane on top of the beams, because there's your rails running on top of the beam, like the rails running on top of the beam, basically the track where you have your crane mounted to. And what I'm seeing is that your crane is going to run in that direction. It's going to run up and down, up and down. So it's going to go forward and then it's going to come back, and it's basically just conveying, maybe it's conveying like heavy equipment. It's lifting heavy equipment over the floor area, you know, maybe inside a store or something. So usually this is indoor cranes, and they're attached to two beams in opposite sides of each other, and it's basically moving heavy load. Like maybe there's something attached to the beam, like this is your crane, let's say this is your crane beam, and it's basically there's something hanging, and then it's just carrying it on to from point A to point B. So that's the first 10, because I don't want to make the video longer than 15 minutes, and it's already going for 16 minutes. So I'll do the next 10 in the next 15 minutes, showing them out or pointing them all out.